Okay, so we'll talk about maps today. Maps isn't just like these kind of maps that you know about. These road map, for example, or when you map terrain on it. There's more to maps than that. So, for example, here, let's move this here. This is basically a map that has that shows that the city versus country or county is not your political fault line. Okay, it basically is a thematic map, right? It tells you a little bit more about what the country, in this case, the United States, is all about, and lays out in this geographical domain, right? So you can see various areas here. So there is far west, which includes, the Great Plains and also on. Then there's the Midlands, Great Appalachia, Deep South, Tidewater, New Netherland, which is New York, Yankee Dome and El Norte, left coast, and so on. And so this is basically these kind of maps. This kind of map that isn't really cuts across the state line has really developed during the birth of the United States, right? When it was settled from the east to the west, or from the west to the east, right? And this was the Midwest. And when you look at this map, this is basically how the settlers sort of how these different communities, so hang on a second. Okay, sorry, I'm back. So this basically tells a little bit how these different communities sort of got situated in these different places of the United States. So New Netherlands, this was like the port of entry. When you read about New Netherlands here, somewhere here, I forget what it's defined. New Netherlands here. Dutch founded, retains traits from the 17th century, Amsterdam. That's like Haarlem, for example, by the Dutch. Global trading culture, materialistic, multicultural, committed to tolerance and freedom of inquiry and conscience. So this is really sort of defines New York, right? New York is very open, right? There's lots of cultures live there, and it's very materialistic because there's the finances there. So this is sort of, but from early on, right? 17th century, it was already like this. Then there's also, let's look at Greater Appalachia, okay, which is a very large region, right? Goes all the way from Virginia all the way down to Texas, part of Texas, right? So Greater Appalachia is defined as settlers from war. This is from New York Times. I got this from the New York Times, so I didn't write this. Okay, this was in New York Times a while back, and I saved it because I thought it was interesting. So settlers from war-ravaged Ulster, Northern England, Lowland Scotland, deep committed to personal sovereignty and individual liberty, intense suspicions of external authority. So these are the people, basically, they really didn't really like the government at all, right? They wanted to be like by themselves, like sovereign, be like self-ruled. And you can really see this still when you meet these people. They really think like this, right? Still to this day. I have another slide next that will show you more. Deep South is here. This is where Alabama and so on is. This is like Barbados, modeled on slave states of the ancient world. Democracy was the privilege of the few. And basically they were against federal power and social things and this like stuff like this, right? So, that's the Deep South. These New Orleans, this is the French. And Far West, we already talked about Far West. No, settlement of largely controlled by corporations. And via deployment of railroads, dams, irrigation, mines, exploited as an internal colony. This is the big area here, this is the Far West, right? This is a very important region, right? Very big region. Settlement largely controlled by corporations or government via deployment of railroads, dams, irrigation, mines, exploited as an internal colony, lasting resentment of its people, right? Because they were always controlled. Basically, the railway was running over them. and they are basically always always exploited. So what's political fault line? It's just where the political ideology changes, right? It's like goes from one to another, like a fault line, right? Like a canyon, right? It like changes. All of a sudden, it becomes very different. You know, divides groups of different identities. Exactly. You know, in this kind of politics. So let's look at the next map. Now, having this in mind, let's look at the next map. This actually is the map that is the partisan landscape defined by 2016 presidential vote by region. Okay, Trump versus Clinton, where the red states are the ones that voted highly for Trump, and the blue states are the ones that very deep blue states have heavily voted for Clinton. You know, so it's an interesting map because it really tells a story, right? It like goes across all the state lines, goes across everything. It just colors the counties. These individual things are like I think it's electoral counties, or the real counties, maybe the real counties, you know, and so you can see the Greater Appalachia when big time for Trump, far west also big time for Trump, deep south as well. New York and California went like the left coast, and New Netherland, which includes a lot more than New York, and which includes Oregon and Washington here, right? And a piece of this went pretty heavily to Clinton. And when you remember back here what we talked about, the heritage of these regions that cut across the state line, sometimes there's a part of the state that's this, and another part of the state that's this, right? It's really changes, you know, it cuts across the state lines, you know, so that's why there's oftentimes conflict within a state, right? There's the South, and then, so it's not just the big cities, it's really also the regions there, and they influence each other in the thinking, right? Coming from the old days when this country was still settled, right? And you can see this in the elections, right? It's always turns out to be that way, right? Sometimes a little more pronounced, sometimes less pronounced. But these partisan landscapes or fault lines have always existed, no matter when, right? No, it is always sometimes a little more red, a little more blue, sometimes a little less blue, sometimes it shrinks a little bit, you know. We'll have more slides about this. But it's an interesting use of maps, right? It really gives you a lot of information, and you know, so I thought that would be interesting. So then we're going to get back to this a little further, because you know the U.S. is pretty politically very interesting. So lots of people have used maps to explain certain phenomena, and they'll talk more about this in a second. So here's the satellite view. This was like similar to this, right? It's a satellite view, and this is the landmark view, you know, where you basically, you know, I'm not here, but this the person who took that picture was here. I'm not here. So, you know, I'm here actually here. So, you know, you can see the trains, you know, basically the trains and the transportation, subways, and the Metro North, like that connects you to Connecticut and the north of New York. Like Westchester and so on, right? Amtrak is here. Subways are shown. There's the green line, there's the red line, the yellow line. The Q train is not shown because it's an older one, right? The Central Park, and so on, right? So it's pretty interesting. So by the way, I recently read like a New York Times article, like on how. This is actually, I should have put this map into this presentation, but I forgot about it. So when you look at these, and you look at the real New York City subway map, you'll see a lot more detail, right? There's like this is not just this sort of very curved line. It's very, very sort of very detailed. Sometimes there's just a little swing in it. It's because this was drawn by someone, I think it was a Japanese person, who took all the subways and wrote it with the eyes closed, and drew where the body was moving. Like when the line was a little going to the left, he drew a left curve, and when the subway was going a little bit to the right, he drew a right curve, right, to really experience the that really experience the rail the way they were laid in the tunnels, and then he would draw a map exactly based on that experience. And that's why the map, the real New York City subway map, looks oftentimes very curved and very detailed. Right? I'll put that slide in there. I forgot about it. There was recently a New York Times article about it, which was really interesting, about how these maps actually were drawn. They were not drawn because someone knew where the line is. It was actually, the very small detail was actually drawn by experiencing the line and not by knowing where the rails were. I thought it was very interesting because some of these lines are very old, like from 1900, early 1900, right? So that's why this is interesting. So these are landmarks maps. You know, this is basically just like a hand-drawn map based on landmarks. So not anymore like based on realism, more like based on the way you would drive it. Here's a little more detail, right? This is really just the way you have to drive, right? This is all what you draw. You know, this is all that you draw. You don't draw anything else. Maybe you draw some landmarks, but you really only draw what you really need to drive from Madison to where? Okay, forget. I can't read it. Kalamazoo, I think. So you know, that's basically, you know, like a sketch kind of map. But there were programs that did this. Like early on, 2001, when this sort of map stuff became digital, there were lots of these programs that people would create or make or sell that created these type of route maps. You know, nowadays Google just overlays it over the real map, right? But this was before the Google Maps came up, right? People try to sort of provide interesting ways and useful ways to give people directions. Back before even Google, before even digital maps, you had to actually go to AAA and you get a triptych, where they would give you a map that had like with something like this on it, right? Where you would, like, if you want to go on a big trip, go to AAA, the Automobile Association, and they give you this map, this triptych, that you know where to go. You know, nowadays navigation is easy with Google Maps or on other devices, right? But back then, that's what you got. Okay, so you know, you probably don't know this. So in any case, this is automatic generation of tours. Of course, you know, this is basically a Google map where you enter the destination and the departure place, but it actually creates a sightseeing tour for you, right? It'll actually tell you, okay, here you have to drive, then you're going to see the Empire State Building. Here you have to drive to see another site, like the Lincoln Center or something. You know, it will give you actually a map that sort of, it knows where your very interesting locations are, and maybe you can tell how much time you have, and then it'll create a path that hits all these different destinations, right? And then, you know, you can do all this, right? Nowadays, there's navigation algorithms, right? And then you know exactly what the traffic will be. You can really plan ahead and really can tell, okay, this is how much time I have, and this is all the interesting destinations I can hit. Taking traffic into account, you can create this sort of this automatic generation of interesting sightseeing tours on a map directly. So you can look at the map, you know where you are, and then you can go and look outside and see what it looks like. You know, in real life, you can maybe get out if you plan for this. You know, these are like another way to deal with maps, right? Experiential kind of maps. This is Street View. Probably all know this nowadays. You know, it's integrated in Google Maps. Back in a while ago when it was invented, there was a separate application where you had to go in, and it would basically, this is basically acquired by these cars that take camera views of the surrounding and then stitch them together into panoramas, and then you can navigate that, you know, in an application, and you can click on this arrow here, and then it moves you ahead, right? And you can look around and see what's around, right? You know, you can basically, it looks very realistic. Beginning it was very coarse, but nowadays it looks almost like the real thing, you know, like nowadays, right? Of course, this doesn't look like this right now with this virus, but normally Times Square looks like this, right? So I'm sure you have been there. And this is another application called Street Side View. This is actually a commercial, 2010. This is basically a commercial application where you can sort of look not at the street, like here, but you can look at the site and kind of find out what is there, right? So, you know, Key Bank and Small Talent and Bank of America, Scott Street. You know, this basically helps you a little bit navigate in the aspect of commerce, and so on, right? So this is street side view. Then something we developed a while ago in 2000, also in 2010, what we call is street light view. So street light view basically was born in my problem that when I was trying to buy a new apartment in New York City, I wanted to see apartments, and a real estate agent would take me to an apartment and, you know, go up to 5th floor or so. You know, didn't have that much money, so I had to buy a walk up. So I had to walk up to the 5th floor, and then, you know, and then they would show me what it looks like to the window, and you could look around, and then, you know. But in New York City, I don't know, some of you may live there. What's very, very important is light, right? Light is very important, right? You don't want to live like somewhere where you're always in the dark, like, you know, because another building includes your window all the time, right? Or, you know, so of course, real estate agents often schedule like your appointment with viewing the apartment. You can only go there once or twice, right? And then, you know, then you have to say I buy it or not, right? You have to beat or not, right? You cannot go there all the time and see how it looks like at a different time of the day. So they take you there, and then they tell you stories, you know, say, you know, it's a beautiful, bright apartment, you know, it's great views, you know, no noise, you know. They give you these fantastic stories, and you can believe it or not, right? You basically have to look outside. So I remember when I looked, this one apartment was really close to the apartment I was living in at the time. And I went there every day, like maybe twice or three times for a week or two, just to see like how bright is it really, right? Because I couldn't really go up, so I had to like stand in front of it and look up, and then imagine like, okay, how much light gets into this window. It was like 3 windows I had to point into the south. And then, you know, I never wasn't quite sure. And then as I was walking back and forth, I thought, you know, there should be like a program that can help you with this, right? Why am I doing this by hand all the time, right? Or by foot? So so I got together with a master student, Charles Boho, and we wrote this, he wrote this application where we basically, you know, you can obtain very accurate data about the lighting at particular points of the day and where the sun is. You can get all this information. I think there's a NASA data set, and you can get this information, so you know exactly where the sun is at a particular day of the year, what hour, and you can also get an estimate about the cloud cover. You know, some months are more cloudy than others. Okay, so basically you can get an idea like how much light is actually reaching the surface of the Earth, right, at this particular location. And then you can get a map. You can get geometry data of the buildings. You can get that too. Like at least you can get the heights of the buildings and the footprint of the buildings. So then you can basically build a sort of a virtual world in which the buildings live at the particular height. Then you got the data from the you know, the sun as it's moving and at particular points in time. Then you can know where the buildings are, and you know where the windows are that you want to like see how much light hits it at a particular point in the day and over the year. And you really realize, if you live in New York City for a while, you know, I realize actually in the winter the sun is much lower, more to the north, right? You get actually a lot more light in the winter than in the summer, and then the sun is further up, depending on the tilt of the Earth, right? So it's actually very interesting. So what we did was then we wrote a program that took the light source, the sun, and then distributed a little bit across the sky, did ray tracing, like volumetric, kind of like volumetric ray tracing, took rays, bounced them off at other buildings, and then into the window. So basically it would map how much light reaches directly the window at any particular day, hour of the day over the year, and how much light bounces off the other buildings and hits the window. And then we would also account for, like, you know, what is the surface of the building, right? Sometimes you can actually see this in Google Maps. You can see if it's a dark or a glass window, or is it a bright facade or a dark facade. You can take this into account. And we created these kind of this kind of maps here, okay? You know, where we basically show this we call this the Illumination thumbnail, right? You can see March to November. We didn't have November to March, just, you know, for this particular picture. And what it shows you from 3 to 8, from 3 p.m., 12 p.m. into this is the morning. And I think this is mislabeled maybe, but any case, oh, from 8 a.m. to 3 p.m. I'm so sorry. Yeah, this is a top down. Okay, 8 a.m. over the day, top down, right? Top down. This is the 8 a.m. 3 p.m. Okay, noon. Okay, and this is March, November, and basically every hour and every day is like a pixel, and you just basically just light up how much light has hit that particular pixel at that window at a particular day, at this particular hour, okay? And then if it's more or less, so you can really see, as you know, the summer, you know, you can really see how much in the winter there's not so much light only comes at noon, and in the summer it already comes at 8 a.m., right? So it's nicely modeled. You can also see there's this skyscraper here, or this high rise here, that occludes your view around noon, like a little bit different in the summer than in the winter. You can really see the footprint of this, what effect it has. And here, this is another building, another window, that there's a different constellation. That there's also a high rise, but it really occludes your window more in the late afternoon, right? You know, not a lot more. Here, the window is really nice in the late afternoon. So from this visualization, right, you can get a quick idea, like, you know, if this apartment is coincides with your lifestyle, right? If you're the one who is usually at work around noon, then you may as well take this apartment. You come home at 4 p.m., you got a nicely lit apartment, come home in a sunny apartment, right, welcomes you, sit down on a couch, relax from work. And this apartment here is nicely lit in the afternoon, in the noontime, in the morning. But you know, you're always at work, you never see it, right, unless it's the weekend, right? But you come home and it's always dark, right? So this is a really good visualization just of, like, you know, you can take this further, right? You can then map this, you can take the light that you computed at the window and then figure out how it goes, how it travels in the apartment, and you can figure out what paint you have to pick in the apartment, and you know how to put the plants and stuff like this. So this is all in this, right? So we actually have a patent on this even. So another interesting aspect of this is, okay, I have like a chat here. Thank you. Yeah, exactly. I thought so too. This person says, this is a very interesting and innovative approach to apartment finding. Exactly, it is. So now here comes the business model. Okay, so I first give you an idea like about business, right? So you have this idea, right, and you implemented it, write a paper and get it accepted, and then all great, you know, and then you actually go out and try. Okay, could I form a company based on this? Right? Why not? Right? Maybe you can develop this app, make it more you know, robust, you know, and sell it. So, you know, then you look at it. So who would buy it, right? So real estate, people that buy real estate in New York, right? Like users like you know, regular people like me and you, right? Okay, they will not pay much for this probably, if they at all, right? Now, real estate agents may like it more because they you know, they have bigger pockets, number one, and they also have more apartments they want to sell, right? And actually, I talked to some real estate agents because I knew some of them, and I was renting out my apartment at one point and showed this app to them, and they said, "Oh no, I do not want this. I don't want my customers to know anything about the apartment. I don't want them to have this information, because if they have this information, I cannot tell them my stories anymore, because now they just say, well, your story is wrong. You know, I see this from this app that you have very different lighting, the way you pretend it, right? So actually, you know, when you think there's like a big gap between a great invention, a nice way to show information, and then how you actually can market it, right? There's actually a big gap between. So we never went with this and marketed it, you know. So actually later on I found out that from another person that I met at one point, and he was a real estate photographer, and he said, and he said this would be a great app for him because he can plan his photography, right? He knows exactly when to visit the apartment. Also, real estate agents actually would like it but for another reason. They would then know when to show the apartment. They would always show the apartment in the bright spots and never even attempt to show it here, right? So it's actually the other way around that they would use it, right, for their own planning, right? So in the event, maybe I should market this eventually, right? So I just haven't really, I don't really have the energy because I market already something else. But in any case, you know, it's sort of an interesting sort of, you know, technology meets marketability, right? And then, you know, you have to think, what is your customers, how you can sell it, what is the application, you know, and so on, right? So I thought it's pretty helpful in this class too, because, you know, one of you may start a business, then, you know, I read a paper that really only 5% of a innovation really is the idea or the implementation. 95% is to figure out who buys it and then how to sell it out, make it profitable. 95% is that, right? Just the marketing. It's very interesting, right? The idea actually is needed, but then 95% of that is actually get people to use it. And here I wasn't sure who would use it and how I can sell it. Now I have some more ideas. You know, I still haven't seen anything like this, you know, but we'll see what happens. Anyway, it's patented, okay? So you have to, if you are marketed, you have to pay me. Just kidding. Okay, so so here's another way of looking at maps. Sorry. Here's another way to look at maps, topographic map. Basically what it does is it basically puts lines around areas that have the same height. Okay, so you sort of see here, these all have the same. It's basically like you slice a mountain, right? You slice a mountain, and then this is basically the slice you would get, right? So this is the one slice, this is the next slice. You know, all of these lines are basically isocontours in terms of the height. Okay, it's like topographic map. Oftentimes these are used, you know, for hiking, for example. This is actually interesting. I've seen these kind of maps, you know, recently I visited, you know, you can see this in I think in Nepal and China, like in Southeast Asia, you can see this often. They have these terracing, maybe in China as well, maybe in other parts of the world too. I just saw it in Nepal recently, where you have these sort of terraces, right? There's like, they basically take the mountain and sort of flatten it in a certain, like along into a certain way, and then they flatten it again, flatten it again, flatten it again. Then they have agriculture on each of these terraces, right? So there's actually a real topographic map in real nature. I took a lot of pictures from the helicopter when I flew up there. So it's very interesting. Okay, so actually these things really exist, not everywhere, but you know, it's not just a visualization. They actually really exist when farmers do this kind of thing. So choropleth maps. So choropleth maps are maps where you try to shade a certain area, like in this case, you know, in France, different regions and like different arrondissements in France. You basically have these, shade them in terms of like some quantity, right? For example, illiteracy in France. Okay, this is like a very early one, 1826. Okay, choropleth maps. So this choropleth maps. Okay, use color shadings to show data, right? So here, illiteracy, those guys, I don't know what is illiterate now. Is it the dark ones or the bright ones? They don't have a legend. Okay, so where's Paris? Okay, so in any case, you know, so this is basically, you know, you can see this. So here's another choropleth map that I wanted to show you. So let's go here. This is Kerry versus Bush in 2004. So Bush was the president and Kerry lost. This was like the race in 2004. Kerry was the Democrat candidate, and this is George Bush, the younger Bush, W. Bush, who in 2004, who ran one against each other. This is the results of the election. Okay, so this is the kind of map that that's the kind of map that the winner, you know, Bush, tried to show a lot, right? To just symbolize this dominance, right? It's by county. The county was colored red if Bush won it, and was colored blue if Kerry won it, right? So Kerry, like, I mean, it's almost non-existent, right? He won like a little bit of California, right? Didn't win much, right? But so if you were Kerry, you would be, you know, landslide win, exactly. It actually wasn't that landslide. So, but we'll get into this. So, but this is a little bit dishonest map, okay? Because it's sort of, you know, the 62 million over 59, right? I wouldn't call it a landslide win, okay? You know, so but the 3 million is not, you know, it's the popular vote, okay? So he did win the popular vote. But you know, the electoral, let's forget about the electoral vote, which is a different animal altogether, just the popular vote. No, he did win it, but not that large, right? If you look at this map, you would never think, you know, when you compare the amount of red and blue ink shown on the map, Bush has like 2.5 million square miles, and Kerry only has 525 square miles, right? This is like the map, right? But so this is really a distortion of the electoral results, right? Bush did win it, but sometimes just by a little margin, by small margin. Even back then was already pretty partisan, you know. So let's look at the more you know, more honest map like this, right? Where you look at the percent, right? This is the percent, you shade it by percent, right? So, you know, basically this is the by percent. So if it's really clear for the Democrats, then you make it very dark, very opaque or very saturated blue. Clear for the Republicans, you make it very saturated red. And if it's sort of just, you know, 60%, here's the map on the side here, 75, 60%, 50%, you know, 50% is like, you know, very light blue. Just a little more blue than red, but almost red, right? It could be both. The same thing here, right? These guys here, they're basically, you know, those are the swing counties or swing counties, right? They could have gone, had maybe 100 or 200 or 300 people voted, you know, for the other candidate, that may have been light blue, right? So this is a little more honest, right? And if you multiply the ink by the if you multiply the ink by the strength of the ink, right, then you come up with a much better chart than this, right? So I don't have that kind of chart. Here, this is by population density. So here you actually do more. You take it and weigh it by the population density. So these states here, you know, I don't know if you ever been there, but there's not a lot of people living there, right? You know, Wyoming and Montana and North Dakota and so on. This just very lowly populated, right? So it's easy to get like 1,000 voters because there's not a whole lot of voters to begin with, right? So here, this map tries to take this into account, okay? Try to multiply by the number of people that actually live there. And you can see these low populated states, which are the, you know, Appalachian states and the far west states we talked about, right? Far west, Midlands, you know, these states, far west especially, you know, far west is actually very low populated, right? Oh, sorry, this is far west, okay. But here, but what's also nice about this is it's really more honest about the Bush, how popular Bush was. Before, you couldn't really see this well, but now you can see it. Bush actually had a really good following in the east part of the United States, right? It's not that bad, right? People would always say, well, Bush no one liked him in the east, but it's not true. He has a very nice shadow, you know, this blue-red shadow, mostly in the suburban areas and the rural areas, but, you know, he has it, right? So, you know, so it's much better visualized now by multiplying. Alaska is white. Okay, yeah, I don't know what. Alaska tends to be red. Okay, most of Alaska tends to be red. I don't know why. Okay, here I see. Yeah, you're right, because Alaska is lowly populated. That's why it's white. Right, there's no one living there. Right. And see, Alaska is not pure red, but mostly, and Hawaii here is mostly liberal. Right, so you can see this too. But Alaska is just lowly populated, and there's a little bit. Anchorage, Fairbanks, and there's a little more people live there. I think this may be Anchorage, but you know, and Fairbanks. But you know, so this is a nice way. So I'm showing this to show you, you know, that don't just, you know, do this kind of thing, right? No matter, it doesn't matter if it's like political maps, whatever it is. Like, try to be more honest about the data. Show the percentages, right? Take it into account and show also more about what you know about the data in the background, like who caused these votes, right? In this case, demographics cost the vote, the population cost the votes, right? To try to take this into account, and you know, and color use this also for coloring, right? This is a much more honest kind of way, and it actually reveals a lot more, right? Here, you didn't see the popularity of Bush in the eastern United States. Here, you can clearly see it. You can really see these are the metropolitan area that are mostly Democrat, and here you see the suburban voters and the rural voters are mostly Republican, right? You can really see this, right? So it's actually really true most of the time. But you know, so another one is here. This interesting map here. This gets me to a different way of showing map, which is distortion. Here we used mostly color to sort of make different maps, right? To modify the map by color. Try to use color for this. Let's talk about distortion. Okay, you know, spatial representations of you know, number of people that live there. Okay, here we use the weighting, right? But here we use distortion. So this is again Kerry versus Bush by state. Okay, you know, this is here. Okay, and okay, by state. And then this is a map that is created by scaling each state by the population. So you can clearly see, you know, let me fill this up here. You can clearly see here that you know, that California is much bigger than here, right? So California is blown up because a lot of people live there. And these big far west states, you know, which are like not many people live there, they get compressed. Texas, you know, still is actually Texas quite big, right? And not as big as California, almost as big. You know, then here also the East New England states and so on, right? They're also very, very populous, right? They get basically expanded a lot, right? Get expanded a lot. And right. And then here also this is yeah. So this is basically a map that, so now you can already get a little bit of more impression who, you know, the one person, one vote kind of thing, right? Where you show, okay, who voted, right? Who actually had the right to vote, and who you know, they don't say who voted, but maybe who could vote, right? Could have voted, because you don't know who. I don't think this map's taking account the participation, which would be another interesting kind of factor to put in. But you know, so anyway, so this is a much more honest map, right? So now the number of red, the amount of red ink has shrunken, right? But you can do more. You can do by county, which gives you a better resolution, right? So if you have only state, you only got 50 plus District of Columbia, right? So, but here, you know, then here you have a lot more, right? You have like 3,000 plus counties. Okay, I think 3,008 counties, and you get a lot better resolution out of this map. Okay, and then you can of course distort it again, which looks like this. You know, so now you have a better distortion than here because it's more fine-grained, right? You can really see now some counties in California and Washington and Oregon actually voted red, right? And you can see them. So they also had a lot of people live there, and they didn't just average out now, right? Before they got averaged out, right, and made all blue. Now they actually have a way to participate in this map building, and the map gets more detailed, more honest, even more honest than it was before. Okay, so you know, then you can go and apply this weighting by percentage. Okay, now it's percentage. This was just who won and who, you know, here's weighted by percentage. So now you get a lot more detail out, right? And then when you distort it, you get this, right? So now you can almost see everything is sort of, you know, not quite red, not quite blue. It sort of has this, you know, magenta look, right? So, you know, so this is really sort of a good map, right? You can really see, well, this is actually, you know, you can really see what the map is, what the US is really about, right? There's like very strong divide, everyone is sort of, you know, it's very split, right? And almost evenly split, right? Sometimes a little more red, sometimes a little more blue, but it's sort of nicely shown that it's really polarized, but you can really, it's balanced, almost balanced, right? And there's only a few hot centers here, very tightly blue, and here very tightly blue. New York, very tightly blue. Even California is not as blue, you know. So, and you know, here is another one. So, you know, so this is, so I thought this was a really nice way to show data, right? Because you take everything into account, not just binary voted yes or no, but also the maybes, right? The probabilities get also moved in. People are not that good at probabilities, right? What it really means. So you may just make a map of it, right? So I have a Republican friend. He's very deeply Republican. He hates these maps. So he would always show me this map here, like this was like not the Kerry versus Bush. He showed me the Clinton versus Trump map, right? He showed me like this map, like something like this, and said, no, don't look at this map. Look at this map. This shows, your guy wasn't really that popular, it wasn't that amazing, right? So, but people that, lots of people think very binary like this when it makes the argument, but as an honest visualization expert, you should really be honest and take all the factors into account and show them at the same time. Like with a map like this, spatial distortion very nice because you can, you can still use color for something else. Right? Spatial distortion tells you like about the quantity without using up any color channels. Right now you can use color for something else, right? So you can now use color to represent a percentage margin, right? So it's a very nice sort of way to combine things. Percentage, like spatial distortion, which doesn't use up any color, just shows the spatial extent of things, maps these proportions to spatial extent, and then you use color for something else, right? So it's a pretty nice way to show geography with data on it, okay? So another one, so is there any questions on this? So I'm gonna kind of leave this. Yeah, as the saying, data tells a story you want to tell. Yeah, that's true. Yeah, that's true. People choose the visualization that they want to show, that they want to make this point, and they use this visualization. They want to make this point, they use this topic, this visualization, right? So yes, there's always a visualization that makes your point. And of course, you can always argue, but I tell you, this makes a better argument just from a theoretical point of view, because I take more information into account, right? This really takes a lot more bandwidth of data into account than this one, right? So whoever argues with this kind of visualization loses, because it only uses yes or no, right? And this one uses percentages and distortion, right? It uses basically all the information I have, right? Or lots more than here, right? So just in terms of information, that I take into account, this one is really a big lie, right? And this one is much more honest, right? I don't say that I like this, because I'm, maybe I'm more of a Bush or more of a Kerry, and I like this map better or the other, right? Just saying, if you argue, look at Long Island, right? Yeah. That's good, right? Long Island, it got really big, right? There's a lot of people living. This is Long Island, for those who haven't noticed, right? So this is really big, right? I think it's long. Yes. So yeah. So so you can study those maps for a while, right? And just it's just very interesting, right? You can it really shows you how big Long Island really is in terms of people, right? New York City is also massive out here, and this whole blue thing is New York City, right? And you can also see Suffolk County, is more mixed between Democrat and Republican, while Nassau is much more leaning the liberal way, right? So you can see actually Nassau, Suffolk County, where Stony Brook is in, has a Republican Congress representative, right? So actually Suffolk County is sort of more of a mix, but not very big, not very marked mix, than here, right? But you can see it, right? So it's just, I like these slides. I like these kind of visualizations because they really use a lot of what you have in your toolbox, right? Like spatial distortion, and it uses color to make a point. So let's go further and talk about different ways to flatten the Earth, right? So the Earth obviously is spherical, right? It's hard to really show them on a single display. So this has been like, the problem of many hundreds of years, right? How can I flatten the Earth, right? So there's all these different ways to do it, right? So I want to show you a video of someone, actually Jarke van Wijk, whom I know. He's a really famous person in visualization community from Eindhoven, and he made this very beautiful video. So basically, he took the Earth and cut it in certain ways to unfold it. So you can actually do this by hand, but you can also do it on a computer, which he did, and just look at different ways. And each of these cuts shows the Earth shows different aspects of the world, right? Shows different sort of communities, right? You can cut it in certain way that shows the poles. You can cut it that shows the North American continent, right? Depending where you cut it, you can preserve continents or big masses of land, right? You can cut it the right way, and it basically unfolds it. Okay, so let me just show you the video, which is quite amazing to see. Okay, so at one point I should probably undo my speaker so you can hear the sound. Okay, I unplugged the speaker now. So now I just have to make sure the sound is actually on. Okay, yeah, good. Okay, so let's go and see this. Can't see this. Okay, so this is the video. If it plays, there's no sound. So das wir sehen, right? So this is a more ocean-centric view. This is more land mass-centric view. So this is a good video just to show you like different ways that you can cut the spherical. So this basically stops again. So I give the URL, I give the YouTube link. It's actually on YouTube. I can give that. You can watch this for hours. Okay. So this is another one another map I got that uses all similar distortion schemes that I showed you in the political one, right? So, but more global now, not the US. So you can. This is basically just. I think this is map based on population. I think this is just, I don't know what the color is. Okay, I don't know what the color, I can't read it. Next, okay. This is just to, so here, you see China and India, Nigeria and Brazil and US, and there's the UK, and this is France, this is Germany and Belgium and Netherlands, right? And Italy is here, right? So I'm not sure if this is this already this is population based. Okay, sorry, it says population based. So this is population based. Okay, so this is basically not the world. This is basically already distorted by population. Okay, so India obviously has a lot of people. Many of you from India, right? So you would know that. Pakistan has fewer. Bangladesh actually also has a lot of people. I don't have the real map. Should probably put the real map there. You can see that Bangladesh is of course not that big, right? As you know, Nigeria is also not that big, right? It's much smaller than this. So it just tells you it's overpopulated. Egypt, Brazil, Brazil is sort of, not too bad distorted. United States not too badly distorted. So when things are not that much distorted, you can tell there's about, it's the right size of country for the people, right? Obviously UK. UK is massively big, right? Much bigger than it should be. So there's a lot of people live there. Germany is also bigger than it really should be, and then so on. Right? Ukraine, Italy is much slimmer in reality, and Turkey actually is much thicker, much bigger. But when you look at the real Turkey, but it's actually Indonesia is also very big. Of course, there's Indonesia. Okay, that's right. Indonesia is huge, right? It's overpopulated, right? There's a lot. Japan has also 130, like more than more than 130 million or more. Like Korea is also very big. China is also way bigger than Indonesia. So anyway, so this is basically a map distorted in terms of this, in terms of population. What's nice about this is, right, you can really sort of start a conversation just based on that, right? You can just look at it and see it, right? Here is one that's GDP, okay? That's the gross domestic product, okay? You can see, like, when you compare it, GDP is way bigger than the population, right? So obviously, it tells you that that the people are very rich, right? So because when the population is this and the GDP is way bigger, then there's a lot of money there, right? Mexico is actually teeny small, right? So you can see that just as a relation. You can see Mexico, that's where the, it's a little poorer, right? And here, lots of people live in Central America, but the GDP is actually teeny small, right? So this, you can see there's a lot of poverty going on. Brazil is still the fat cat here, and then the other ones are slimmer. Then India has disappeared. Well, India has shrunken a lot, right? China has shrunken a little bit too. It's always amazing to me how Japan has grown so much, right? Because so much GDP coming from Japan, right? So much is produced there, right? And Korea, the same thing. South Korea is also. North Korea has almost disappeared, right? North Korea was here, has almost disappeared now, right? Also appeared. What is this? Russia. Well, Russia is also very slim, and the whole Africa. The whole Africa is actually gone, right? Look at Africa. Right? This used to be Africa. Now it's like this teeny thing, right? Because nobody there, right? Germany has grown a lot. France is big. Germany is big. Spain is not as big as France. But when you look at France and Spain, Portugal, sort of similar, right? It's UK. So anyway, so by using these distortion techniques, you can really, and comparing different maps with one another, right? And maybe you can animate between them, right? And then you can really observe it, right? If I made this PowerPoint slides with animation, you could, what happened to Indonesia, right? Teeny small, right? Got very thin. Okay, it used to be really big, tiny, right? So, so this is very interesting, right? Just by distortion, right? So spending on healthcare is very interesting too. Okay, so US, not too much difference between GDP spending healthcare. China spends a lot more. Japan has a little less. Korea is similar, where it's like some changes, not a lot of change that I can observe. This, spends this a little more here. That's Argentina, I think. So here, and then this is also interesting, energy consumption. So who spends a lot on energy? Japan, again, lots of energy. Korea, actually not that much. I think this may be an older slide. Japan spends a lot, and Korea doesn't really spend a lot doesn't consume a lot of energy. China doesn't consume a lot. India more. The US also, and then Mexico consumes a lot of energy in respect to the GDP, right? And healthcare. It consumes a lot more energy. This also changes this one. That's Iran, spends a lot of energy. Okay, so so these distortion techniques can really help you. South Africa, okay, South Africa. Yeah, that's right. That's really interesting. South Africa is amazing. That's right. South Africa is here. And then it's just the only one in terms of GDP, healthcare, and energy, right? Because it's a very rich country. It's a pretty rich country, right? It's like civilized, more rich, right? I have some friends live there actually, and they live pretty well. So this greenhouse gas emission. Now you can really see who are the people that really pollute the environment, right? So South Africa is obviously, in terms of consumption and energy greenhouse emission, they have just very dirty dirty energy, right? They you know, that's very dirty here. China also, and then you know, India is this one. India also is a big polluter. Okay, U.S. also a big polluter, and here Europe, of course, you know, Germany is, and all these countries, you know. So Africa doesn't really pollute much, right? They don't, because they don't have anything to pollute with, right? So anyway, this is very interesting, right? Just by animating it, okay, you can learn a lot about these different factors. You know, Russia also greenhouse gas emission. So you know, so it's very interesting to sort of look through these and go back and forth between them and sort of compare, you know, what these, you know, what, you know, how these things go together, right? Gas, for instance, very interesting is the energy consumption versus gas, greenhouse gas emission. You can sort of see who has the dirty energy and who has the clean energy, right? So Germany, that tends to be, has the clean energy, and you can see it, right? Greenhouse gas, it shrinks, right? It's shrinking. Germany is shrinking. All the European countries are kind of shrinking, right? Because percentage-wise, other countries take up more, right? Actually, you know, US doesn't do so bad either, right? Greenhouse gas emission, okay? Now this one grows, China grows, right? And then you know, the European nations get smaller, you know, when you look at, you know, so because there's a lot of green movements in European nations, right? There's a lot of people that want to like reduce the energy consumption, right? So there's a lot of trend to have solar panels and wind turbines and things like this. You see this a lot in Europe, and now starting to see it in the US too, but in Europe you see it everywhere, you know. So anyway, another few slides I want to talk about is this airline's view of the United States. You know, this is how the airlines view it in terms of the distance, right? You know, some things are very close, DC and New York, because there's a lot of shuttles, right? And then, you know, San Francisco and Oakland is actually far away because there's not a lot of planes that go from San Francisco to Oakland, right? Oakland is actually very close. Denver is but closer. There's a lot of shuttles that go from San Francisco to Denver, right? So this is basically the way that the airline view of things, right? You know, then you know, then not so much the geography, it's just the way you can reach, you know, by distance, airline fares. Okay, this is basically airline fares. So, you know, no one would go from San Francisco to Oakland because you can just take the car, right? And because you have to, if you want to go from San Francisco to Oakland, you have to go to Kansas, then go back to Oakland or something like this, right? And there's also DC is very low, right? Shuttles from New York to DC are very, very cheap, okay? So this is like a nice way to scale a map in terms of the, you know, like you can sort of tell you, like, you know, how far away things are in terms of dollars, right? And then you can look at it. Wow, you live in Cleveland, man, you're so far away. It'll take my wallet. You have to sink a lot of money out of, take a lot of money out of my wallet to go there, right? I rather have a friend in Boston because it's cheaper, right? And stuff like this. Major cities population, okay. Then this is interesting. These are these rectangular cartograms where you basically try to represent countries not as, you know, in this sort of curved way, but you try to normalize them more into like squarified or these kind of, you know, rectangular cartograms. So you can get a little better grip on compare the size, right? You can compare the size better. You know, they look a little like Lego, right? But it helps you really you can sort of start to count squares now, right? Because they like to live on these squarified grid, right? And you can kind of get a little, you know, of course you would probably not count the squares, but it helps you because you have sort of it's a regular Cartesian grid, right, with squares, right? It helps you to better appreciate similarities in size, right? And also shape, you know, it's because it's no longer curved, where there's a lot of sort of different kind of in you know, concavities and convexities. Now it's much more, you know, unified, right? So this is basically one way, a better way to look at, more comparable way to look at maps. Another one is rec map. Basically, this is basically just a tree map, the way we looked at it before. And here, taking these tree map squares and maybe squarifying them a little more in terms of the size of the actual country, state, and aligning them up like this, right? So this is really now, you know, in terms of the neighborhood, it's sort of, you know, you have to optimize it, but it's sort of neighborhoods are preserved, right? Neighborhoods with Oregon, boundaries, California, Arizona, Nevada, right? Washington doesn't touch California. Of course, it only touches Oregon. You know, this is Idaho, right? And this Florida touches Alabama, Georgia, and Georgia touches South Carolina, North Carolina. North Carolina touches Tennessee. Tennessee touches, you know, Missouri and Arkansas and Mississippi, right? So you can sort of see where your neighborhoods are. You can sort of go around and look around, and you can get a little bit of a sense of the population, right? So it's basically a nice sort of way to look at maps more in a appreciable way, where you can then if it's more interesting to you, to like reachability is more interesting to you, and population size is more interesting to you, and you try to sort of make them square so you can easily compare. Sometimes you can't because the way have to okay, here we go. So this is now, you know, South Carolina and so on, right? So you can sort of see this is a nice way. And here's the ultimate one, grid map, where you really take those states and abstract them even more into actual similar squares. Okay, now you know you can states with bands and same-sex marriage. Okay, this is a very old map. Okay, it's nowadays much different, but in any event, it tries to sort of really make it easy to understand. It's now the distance that the neighborhoods are not as well preserved as before, because some states, you know, have more than you know, more than eight neighbors. You can only get maximum 8 neighbors out of this, right? So in some, and if you're on the coast, you can actually get less. But now it's even easier to see, right? This is a little more neighborhood preserving or eligibility preserving. Now this is a little more like organized, right? And then this is just a different kind of coloring. So it basically now it's more like it gets rid of all this stiff stuff with size, right? It basically just every state is the same size, and now you only use color to differentiate, and they have a little bit of encoding of proximity, right? That's a little bit in there, you know, but not as much as before, right? But now, you know, you can quickly get an overview. So how many states have bans on same-sex marriage? It's easily done by the brown ones, right? So, you know, and here, how many, and where are they? Which ones are there? Are there clusters, right? Obviously, there are clusters. You know, there's a cluster here, you know, and here, state allowed as civil unions or broad domestic partnership. Again, this is a very old map, okay? But, you know, these are basically the ones that do and the other ones that don't, right? And so you can sort of get quickly an idea of like where the clusters are, where people think the same way. Remember what I showed you before, that you can take the whole United States and sort of look at these sort of ideological clusters. And then you can sort of see that here, right? You know, so this is obviously a cluster, Oregon, Nevada, and California, they all have this, right? So basically, you can sort of see how an idea has spread, right? California maybe had it first and infected Nevada, and then they infected Oregon, right? Something like this, right? You can sort of see how an idea spreads, right? Or how an idea hasn't reached yet, right? On one or the other way around, right? Because of this proximity, at the same time, it's organized in a grid. Then next is another grid map. So this is a hexagonal grid map. It's very similar to the grid map that I showed you before, but just now it's hexagonal. What it buys you is you can have more neighbors, right? So now before you only could have 4, now you can have 6, right? Now you can have 6 neighbors, you know. So neighborhood is better represented now. You can like see that California borders on Oregon, Nevada, and Utah, and before you could only do Nevada, Oregon, right? And now you can do more, right? You can basically get a better way, but of course, not every state has 6 neighbors, right? Sometimes they don't, and so sometimes, you know, maybe some false neighborhoods are created. But it's, you know, it's another way to represent. So it's like hexagonal grids are more of a tight representation than square grids, right? You can get more connectivity, more integration than you can get with square maps. So there's a lot of theory on these lattices, and hexagonal grid turns out to be the most space efficient grid that you can find. So this is just another way for politically speaking, right? So it's basically just another way of these square maps that I showed you before. This is another way of these. Now it's in the county. Okay, Democratic district, Republican district. Okay, that's the counties. So, okay, So similar idea. It's a similar idea here. Okay, this is a map where you what's in a surname. Like basically now the map is created, but you make a word cloud out of it. So now you basically print out like now you print out like what is the predominant name, last name or surname, right? So here the Smiths live here, Williams live here, Jones live here, Andersons live here, right? And it's sort of a very interesting map, right? Because it gives you like the semantics of, surname, and it may give you also a hint on like what our kind of population looks like, right? You can see here Rodriguez, Gonzalez, Sanchez, Martinez, Riviera, right? So these are all, it must be Hispanic neighborhoods, right? Because they have Hispanic names. Here, Anderson, this may be more, Swedish or something like from, Anderson is a Swedish name, Anderson, William, Smith, Jones, Wagner, Thomas, well, these are maybe German, I don't know. Anyway, to get what's nice, what's really the most interesting is really this, Irish, O'Brien, Kelly. And it's actually colored by green, right? This must be McCarthy. This must be like the Irish folks, right? The Irish folks. If there's some Irish enclave here, Kelly, Murphy, Kelly, Snyder. I don't know. It's like written somewhere here. I forget. So I think the Irish are here, and these are the Hispanics. There's Rodriguez again, right? And these are the British, Anglo-Saxon, right? So anyway, this is like a nice representation by last name what the community is all about, right? It's also like a map, right? So this is a map of New York area by racial and ethnic groups. Okay, so basically a pointillist rendering of some sort, right? Pointillist kind of rendering where you say that the whites are the green dots and the blacks are the blue dots, and you just put a dot like per 100, 200 people, right? You put like a dot there, like a pointillist dot, just put a dot there, and then you can have more dots in a certain particular area because there's, your dot doesn't take much space, right? So you basically you can show it like this. And there's just less people living here, more people living here, right, in Manhattan. So you can really see white neighborhoods, you can see Hispanic neighborhoods, you can see black neighborhoods. In here, this is all black neighborhoods. Here, this is the red ones, the Asian neighborhoods. This must be Flushing. And then it transcends out here. This is Chinatown, also very heavily Asian, right? And it's very easily done, right? Not very hard to do, right? All we have to do, figure out what is make like a dot per 200 people in that area that have this ethnicity, right? And then just render this like this. And it's very, very informative, right? You can really quickly see there's a lot of continuity, right? You can really see what these different neighborhoods are. So could be worthwhile for, for lots of things, right? Voter patterns and real estate, whatever you want. The school district, like figuring out where you want to live. This is a very helpful kind of, because it has a high granularity, right? You can really see by visually integrating over these neighborhoods, you can sort of see where, what is the predominant ethnicity in these areas, right? So here's another one, flow map, transportation of pedestrians in Ireland. This is the Minar map that I showed you already before, like Napoleon's crusade to Moscow and back, right? We talked about this before. There's another flow map layout. This is the pattern from states into other states. And this is the time varying map. 12 a.m. Sunday, like what is the traffic around, where people are. So another one that's interesting here is this one here. This works for everywhere, right? Like if you want to, like let's say you have this multinational retailers building a discount supermarket 28 miles from one of Mexico's most treasured ruins. This is like a newspaper article, right? The pre-Columbian city's mighty pyramids dedicated to the sun and moon tower within view of the Bodega Aurrera Walmart subsidiary, right? So, but then you would think like, how much it really is 28 miles, right? You may not really know what it is, right? So what they do then, they basically try to make a map that show where 28 miles is, but within respect where you are, like, you are here, San Jose, and Yahoo is here. Okay, so now okay, well, I work at Yahoo, right? 28 miles, now I know what 28 miles really is, right? You know, or here, you and University of Washington, right? It's 3 times longer the distance with you and Yahoo, right? 3 times more. Okay, 28 miles is actually 3 times more than that, right? And 8 times more than the distance between you and University of Washington. So depending where where you Seattle, University of Washington, 28 miles is actually 8 times more. Gives you like a little bit of a way to compare these distances, right? You can sort of figure out, it puts it in perspective, right? You can get a better appreciation what 28 miles really is. If before, then you may think, oh, 28 miles, that's really actually pretty far, 8 times more than University of Washington. Takes me already a long time to get to University of Washington, that's 8 times more. Oh, it's okay, I mean, maybe it's okay, maybe not a big deal, who cares, right? But in any case, you never, it personalizes this distance in terms of what your horizon is, right? Which is a nice way. I've seen this in visualizations before, like recently, when like by plotting distances into like a common frame, into a frame that is very personal to you, you can get a better way of really appreciating how big it really is. So this is really a good way to do this, like finding these correspondences, right, and putting it in your own frame of reference. Okay, so it's a really good way to visualize things that may be fuzzy to some people. Put it like in a perspective to the actual person. Then you can make a much better point of your argument. Okay, so I highly recommend this kind of thing. So this is another thing that I found interesting. People often think this is the East, this is the West, but then this is called the West, and this is called the East, right? Although it's kind of interesting, to think about that. What I also want to show you is, like, I want to spend like a fast 5 minutes on this, on colorization of, like, if you want to have like maps that have more than one variable, right? Before, the variable was just voted for one candidate or the other, right? This was just a single attribute, right? Or other attributes. Oftentimes these maps only show you one attribute at a time, right? These choropleth maps only show you one attribute at a time. But if you, let's say, what if you had like, more than one attribute, right? Then what do you do? Right? For example, here is this 5 personality traits, very, very heavily studied in psychology, right? A person's personality can be expressed in 5 dimensions. Okay, openness and conscientiousness, extraversion, agreeableness, and neuroticism. Right. So this is basically every person has sort of different percentage of these kind of things. Okay, this is like very well studied in the psychology literature. Okay, so then people have actually studied the countries, okay, the states in terms of that, right? They went around. There's a questionnaire, has a 50. There's a long and short questionnaire. You can take it. You can find it on the internet. You can figure out if you're more open, if you're more conscientious, if you're more neurotic or more agreeable. That questionnaire will figure it out. Okay, so you can take that. It takes about like half an hour or so to take, depending on the length of the test. And they did this basically for every U.S. state. They went like, every U.S. state, they took like a good sample. I don't know how many I don't know what this is based on, 500 people per state. I'm not sure, and figured out how open or extroverted, how people did on those tests, and then average everything, and then figure out if it's statistically significant, right? And then sort of here is like these different personality traits. Okay, neuroticism is here, then agreeableness is here, conscientiousness is here, openness is here, extraversion is here. So so you can sort of see, but you can really, it's nice to see. So there's like West Virginia seems to be very neurotic, right? Then Utah seems to be very conscientious, and then extrovert. That Virginia is here, right? Utah is here. That is Wisconsin, I think. So in any case, so you can sort of see, but it's hard to really compare, like how similar are these states really, right? So what you can do is you can use this visualization here, this mapping here, to create colors that are sort of combining all of these different traits in a single color, Okay, so remember I told you about Radvis, right? Radvis, that where you align, where you put different factors on the periphery, and then you figure out the point. So this is the point of a state that is like more neurotic. And here's, you know, depending the mixture that you have in these 5 variables, you're going to be laid out in this Radvis display. And you know, so this state is heavily neurotic. This may be Virginia, West Virginia, right? In this case, it's more conscientious. This may be that may be Utah, right? So, and then the other ones are sort of a mixture of everything, right? Some are a little more biased towards this, and some are more biased towards this. So basically, you lay it out in this terms of like this display, and you can also see like which traits are more correlated because they're going to be mapped closer together. Like conscientious and agreeableness seem to be very correlated. So people that are more agreeable tend to be also more conscientious. People that are conscientious, they tend to be less neurotic or more neurotic, depending where you go. Openness sort of between neurotic and extroverted, right? So in any case, this is just by correlations. Then you can create a coloring like this, which is basically just taking the states, mapping them into this way, where you just figure out the weights by how much value they had for each of these attributes, and then you colorize it, right? So now you can sort of see, well, these are very similar, right? California and Nevada are very similar, you know, in terms of all of these different attributes. So they're heavily open, they're very open, but they're similar. Here, this Utah is very different. Why is it different? Because they're conscientious, right? But they're not very open, right? They're just more, you know, they're not that conscientious, right? But they're more like, that openness is really their main trait, right? Here, these guys are more neurotic, right? And this is heavily neurotic. And this guy here is extroverted, you know. So in any case, this is sort of a mix of everything, okay? Florida is a mix of everything because lots of people move to Florida, so it becomes like a mix. So, you know, so this is basically a way to bring all of these together in a single display, right? By mapping it first to this display, put a color map underneath, and then visualizing like this. So this is work that was done by a student of mine, Shengwei Cheng, and myself, published that maybe 3 years ago. Another thing I wanted to show you is this one last video I want to show you, and then we end this lecture. So this is basically a way where we try to map, where we try to mix information visualization and geo-visualization, geospatial visualization in a single display where it's a dashboard, okay? Like remember dashboards, we talked about dashboards, and you're all supposed to do make one. So let's talk about this, right? So this is a scientist that I know from, who I work with at the Pacific Northwest Lab, Ala Silenyuk. She has this particle, it's a spectrometer that sucks in particles, then destroys them, and then figures out the spectrum of these particles, like what mass, the different mass, basically what is the particle made of, you know, like the spectrum, the mass spectrum. Goes out as an airplane, this is inside the airplane, flies somewhere, and then sucks in a lot of particles and measures what they're made of, right? And this is like a typical flight path, okay? Then this is basically the interface that we have created, okay? So, and the interface basically joins Google Maps, Google Earth, together with the information display, okay? Information visualization display. So this is a different data set, okay? You can take these dimensions of this different, the longitude, latitude, the year, and the depth, temperature, salinity. These are different measurements on the ocean. You can see, you can go take this para-coordinate display and like choose what temperature you like, what salinity you like, which latitude, longitude you want, and then highlight that here in the display. At the same time, you can also circle on the Google Earth different regions and see what salinity and what temperature they have, right? So you can go both ways. You can take the information display, map it into the geospatial display, or you can take the information, or you can make the geospatial display, highlight a few things, and see what parameters they have, what values they have in the geospatial display. So, you know, so basically this is the pipeline. So I show you this video, and then this has sound.
In this video, we provide a demonstration
which basically displays.
of our interactive visual analytics framework for exploring geospatial data with linked multivariate information displays. We start by exploring a dataset of oxygen concentration in seawater. The system features a parallel coordinates plot of the data shown on the left and an interactive 3D geospatial view shown on the right, which we generate using the Google Earth API. Here the analyst is browsing the dataset and interrogating a few data points individually. The points are highlighted in the linked parallel coordinate view as he clicks on them in the geospatial view.
So it's a signal.
The analyst uses the brushing tool in a parallel coordinates plot to filter out certain data points and view only those he is interested in exploring further. The geospatial visualization is updated accordingly. The analyst has just switched to our innovative correlation viewer. Here, a correlation is visualized as either a quadrilateral or a bow tie, depending on whether it's a positive or negative correlation, respectively. The user has just filtered the data using our automated brushing tool to show only those values which lie within a few standard deviation of means along each axis. The ranges along the dimensions change as he increases or decreases the number of standard deviations he wishes to visualize. Now we will explore the indirect and semi-direct aerosol campaign dataset, which was obtained from aircraft flying over the North Slope of Alaska in the United States in 2008. The user performed some brushing over the dataset to begin the visual analysis. Note that a tooltip appears to assist the analyst in performing accurate brushing. Our framework enables the analyst to view details at individual sampling points using a unique set of glyphs we have designed. For example, here we see the use of a pie chart to show particle compositions at a particular sampling location. An embedded histogram shows another view of the data. Various parameters of the glyph can be changed at runtime, such as the number of bins in histograms. Note that the geospatial view is linked to a histogram viewer in the middle of the viewport. Clicking on the histogram on the right will also affect a change in the viewport on the left. We can also dynamically scale the glyphs as a function of a particular attribute, which the user is doing now for the NSPLAT attribute. Now we will explore a case study from the Alaska aerosol dataset, which was conducted in close collaboration with climate scientists. First, we follow the flight path that the aircraft actually took as it sampled the particulates in the atmosphere. On the geospatial display, we can use a series of mouse clicks to draw a selection region around sample points that are of particular interest. The points inside that region are then aggregated and shown as a single glyph that summarizes the enclosed data values. We find that the glyphs show significant spatial variability in particle compositions and sizes, which is consistent with the previous report of a highly stratified atmosphere. Most of the particles are biomass burning particles that were transported over long distances, during which time they absorb sulfates and additional organic substances. Now the analyst is going to study the particles that lie between the cloud droplets. He does this by clustering them manually and then renders them in red. Then he selects only the cloud droplets themselves and puts them into a separate cluster, which is shown in green. Next, the analyst visualizes each cluster using a glyph. We find that the two pie charts are virtually identical, meaning that the particle compositions at the two locations are very similar. This was a significant scientific discovery. At a certain point in the flight, the aircraft ascended to 7,000 feet along a spiral trajectory. This can be seen in the 3D geospatial view on the right. Now we see as the analyst explores the samples taken during the ascent. thus revealed that the particle compositions change significantly in altitude, and furthermore that the changes are not monotonic. This also was a scientifically important discovery.